Okay, good evening, everybody, or good afternoon, in fact, much better word. Good afternoon. Okay. This is Dr. Shaheen Mansour, and I have many of you are online. You are very welcome. For those who join me online, for those who showed up here in Fresno, that's good. So if you look to the course outline or the syllabus, as we call it, or the let me see if I can get one here very quick. You will find that the surveying class, let's go to courses, our website. Let's go to surveying. Okay. And you will find that some reason I'm not able to get it for some reason. We'll go to all courses and the surveying. Okay. And here is another engineer coming. So have a seat, please, anywhere you want. Is this Mr. Lee? Yes. Okay, I talked to you yesterday. So basically, the course or the exam, as you know, it right now is given all year round. So a quarterly system. It depends when you send your application, and you are eligible to take the exam on the following quarter that they approve your application. This is a board. This is between you and the board. I'm not involved in that. So I'm just teaching the class. But as far as rules and regulations and anything related to the board rules and regulations, I don't involve in that. I've been doing this for almost 30 years, teaching seismic surveying, 8 hours. I was teaching this morning, the 7 a.m. Using my own books. And also I started using my own books for the last 25 years, or maybe 22, 25, some of them 25. Because the variation from one book to another, and the board, they change the rules and they change the textbook. So I start to use my own books, and all these books are available on Amazon. And the engineers, I believe that they like it according to the rating, and they are happy with it. I try to be concise and to the point. I cannot claim that they are error-free or immune from any mistakes or typos. Like myself, I do mistakes like in other book or other code. But overall, this quarter, which is the first quarter, I'm going to meet in these days. And as you can see, only 15 hours. But you do have access to 42 and a half hours of on-demand. What is on-demand? The moment you enrolled with us, we send you a link. Okay, password and user ID. If you did not receive it, please let me know, and I will talk to my staff. I am in a transition right now because my staff, the old staff already, they already left, and they have a new staff, so I'm training them, and I will do my best to work with you. So if you are enrolled in the class, you have the password after we receive your enrollment and ID, and you will get access to the 42 and a half hours, as I mentioned, 24/7. You can these 42 and a half hours, I recorded before the entire course, and you can watch it 24/7. Okay, it is saved somewhere. You will get access to it. You must have an internet, computer, and internet, and I believe also any media you can access. But computer is much better, but tablets and iPhone and all these things, you can get access to it. So you'll get access to this. We give you access 150 days. From the day that you enrolled, we'll give you access 150 days. All this written on our website. And you receive 4 books from us. This is a textbook. This is a comprehensive summary of the equations. This surveying practice exams, and a book I came up with this book lately is called 497. CBT. We send you also a USB. We send you a green USB. And this USB, it does have, I hired somebody. Let me show it to you, at least for those who are online. Yeah, you receive something from us like this. Let me switch to the camera. I can show it to you. A USB, this USB, it does have a lot of information, by the way. It does have surveying equipment and how to use the equipment and how to use level, stadia, to the light, leveling, all these things. And it does have the 497 problems. And the moment you install this in your computer, it will ask you for a password. The computer will generate the password. We don't generate the password. The computer, the programmer I hired, I asked him, we need a password, okay? And this password is unique for you. Only nobody else can use it, because we will know that. If anybody else will get a notification about that. So, and every time you start the program, it will generate 55 questions for you randomly from the 497. And it will time you exactly 2.5 hours, as if you are in the exam. And you work the 55 questions, and after you finish in 2.5 hours, you will submit your work. It will give you the results, how you did, and it will give you obviously the answers. So this program is very, very powerful. And instead of the commercial programs available in the market, I went this route by hiring somebody. If you have any problem with the program, let us know. I'm not a programmer. I will talk to the programmer and we'll try to fix it, but we don't have any problem with it so far. So, but you need to jump in, and this can generate unlimited number of questions, unlimited number of exams, unlimited number of exams. I'm sorry. Let me take my word, because my lawyer told me that you have to be careful with your words. Okay. So every time you generate, okay, exam, it will time you and will, okay. Some questions will be repeated again. Okay, so the computer will pick randomly, okay, 55 questions. And if every time you push a button, another exam, another exam, another exam, unlimited. Okay, but the word unlimited, I didn't use it. I don't know. I believe on the 497, what word did I use, by the way? I use the word unlimited, but my lawyer erased this. He said random CBT exams will be generated from this. But theoretically speaking, unlimited number of exams, not just only one exam. So the 497, this number of problems, they came from 3 sources. They came from my textbook, okay, which is this one here. This is a textbook which has about 247 problems. So I took the 247 and I took the 2 practice exams. It's 111 questions. Okay, for some reason they came under 11, and I added another additional problems from here and there, and I ended with this number. So this is, they call it the Bible of all the questions that I'm aware of. However, from time to time, I generate additional problems. Like, for example, last semester, I gave them about 60 problems, some of them from here, and some of them from other sources or other ideas. So there are many, many problems that you will be able to work, as long as the exam, as you know, is 2.5 hours, and the difficulty of the exam, the time, the biggest enemy for you is time. So when you look to the exam and look to see how much time you have, you'll find that you have a very, very, very small amount of time for each question, about 2.7 minutes or so per question. Some questions will take about 10 or 15 minutes. This is why you have to be selective. When you go to the exam, you have to be selective. And so for those who are enrolled in the class, you have access to the on-demand. You can watch chapter 1, 2, 3, 4, 5, and after that we'll meet here. We'll go over anything that you want me to go over there. I'm not going to cover the course, because I cannot finish the course in 15 hours, okay? The course is already ready for you. So it is your time right now. And here, I'm willing to discuss any topic or any subject, any problem. I explain it. If no questions, I will solve problems and so on. Okay, this is the way it works. Okay, that and so on. The next after the PE exam, I'm going to teach another full class. This is the second quarter. The second quarter, it has a class 54.5 hours. I will be physically teaching this because I'm going to update my books. Somebody is working right now for the final review that I'm going to come up with the second edition. The difference between the first edition and the second is not too much, by the way. It is just a little improvement here and there, taking care of some typos maybe or mistakes, adding more problems. So the first edition, the one we are using right now, it has been used for I don't know how many years, and everybody is happy with it. As far as I know, you can go to Amazon and you can watch that or search it on the net. But I decided to switch it to the second edition, where I'm going to start teaching the class on April 18th. Okay, so I'm going to start it from scratch. I'm going to record it again, so make it available for the next quarter to be on demand. And I will go back again to the 15-hour course because it will be available 24/7 for the on demand. Okay, as on demand for those who are attended. Okay, the previous one. So I hope that you will pass. If you are enrolled in the second quarter, you are entitled to take this course again with me for free, because will be within 150 days. You can attend again the course, and if you need it. If you passed and you don't like to see me again, I'll tell you thank you. Just enjoy your passing, and if you'd like to come, you are very, but you will be entitled because you probably are, because 150 days you are exceeding the first quarter. So and you will be entitled to take another set of books. By the way, I'll give you another set of books for free, included with the course, because you already paid only once, and I don't like you to charge you twice. Okay, so this is the first quarter. So let me start by saying that okay. No way you could discuss unless they add out of it, probably. So, for example, yes, I'm talking to the engineers who are here in Fresno. For example, if I switch to the camera here, and I have something that's called the quiz 1, and I would be glad to send it to those of you who don't have it. If you don't have it, here it is. Let us start this quiz number 1. There are 12 problems. 12 problems, okay? Let me give you 10 minutes to see what is your effort. Okay, can you start right now? So I'll give you 10 minutes from now to solve the quiz number 1, okay? And the quiz number 1, I know those of you are not here and you don't have it. I will flip the page, but right now, let us get closer to the, I will try to make the camera as good as I can. And here is a question number 1 to number 8 on the first page, and question 9, 10, 11, 12 on the second page. Okay, I will flip the page. I will give you, so 10 minutes, after 5 minutes, I'll flip the page but for those who are here, you are very welcome to work it the way you want. Let's start right now. According to this, I will go with the computer clock. So it is 4:44. So it is 44. So 10 minutes. So 4:54, I will stop. Start now, please. 1 minute to go. Okay, time's up. The purpose of this, not to waste 10 minutes of your time, but just to give you an idea that the surveying exam, the 2.5 hour special surveying exam or California special exam, is not an easy one. It is difficult, and the most difficult part of it, the time. I'm sure that if they give every engineer additional 1 hour, the passing rate will jump from 30 or 40% now to maybe 60 or 70, but the passing rate is very low, 30%, as low as high as 42% to the best of my knowledge. This is based on statistics. So less than half of the engineers are passing the exam. Why? Because of the time. If they give you extra half an hour or 45 minutes, I believe the passing rate will go up to 60 or 70, but for some reason they limit the exam to 2.5 hours, 150 minutes only, and they give you 55 questions. So they are really giving us hard time by giving me too many questions in a very small amount of time. And some questions are really lengthy. The first thing that I always say, when you go to the exam, you must have a strategy. One of the strategy that probably I recommend, but it's up to you. I will read the question, number one. If I can answer it in the amount of the time, which is about 2.67 minutes or 2.7 minutes per question, if you take 55, 150 divided by 55, will give you around this number, I believe, 150 over 55, about 2.7 minutes or so. If you can solve it, check the answer and move on. If you read a question that you feel that you need to open a book to get an equation or a table you need to look to, or definition is not clear to you, and you need to open book, either my books or you are carrying other books, I will move on and I need to pick the questions that I can answer without opening any book, touching any book. The moment you touch a book, you are losing time. And I'm saying that in order to pass this exam, as a minimum, you have to answer 20 questions. If you can make them 25, if you can make them 30 questions, to answer without touching a book. Any book, it doesn't matter what book or books you are carrying. So without touching any book, you read the question and you know the answer. If there is a simple equation like this is a vertical curve. If you practice enough, you will find that the station rate change, or the station rate of a change, it will call it R, and this R is equal G2 minus G1 divided by L, and the G2 in this case is a plus 3% minus G1 is negative 5%, negative 5, divided by 8, which is 800 foot curve, 8, you will find that this is a 1%, a plus 1%. And the answer is B as in boy, and you are going to move. By practice, you will remember this equation. And you'll say, oh, this is a vertical curve. We have the equation y at any distance x is equal the y of the beginning of the vertical curve, which is the BVC, a plus G1x, a plus Rx squared divided by 2. This is the general equation that we use it for a parabolic curve, which we covered in chapter 10 of my book. But if you practice enough, you will remember this equation, and you remember the rate of change in grade per station. So you can solve this without opening a book. You don't have to go to the book and look what's the definition of R, or how can I calculate R, because you practice enough such that you are able to write this equation very quick and plug the numbers, even you don't need a calculator. So this is something that we need to practice to a degree that you are able to solve 20 questions as a minimum. I recommend 25 if you can make it theory without touching any book, without any book or reference, anything. And the remaining questions, the other 25, you need to open, oh, Mr. Mansour's book, he has something. Oh, another book I have has this. What is this equation? What is this table? What is this chart? And some questions are so difficult, it takes you about 15 minutes. Lately, they are focusing on the construction a lot. There are a couple areas here I mentioned, or one specific area, which is this one here. They are not paying attention to this anymore, which is called USPLS, United States Public Land Surveys, which is chapter 14 of my book. I still cover it, but I cover it in half an hour. I told don't spend more than half an hour, just in case if they ask a question related to this, you know what they are talking about. But they are focusing right now based on the current test plan. Always go to the test plan by the board. The California board, they have a test plan. And all these test plans are given at the beginning of my books. Or if you go to the website, you will find that all these test plans are given. Engineering, for example, there are 4 areas right now. It is topographic surveys, construction surveys, accuracy, error analysis, the preparation of reports and maps, and they give us a percentage for each. This is the test plan from California board. And after that, they took each area and they break it down. What is under topographic surveys? They are talking about distinguish the purposes, okay, and the procedure for topographic surveys. Use of datums for horizontal and vertical control. Perform the measurements of elevation. Perform leveling calculations and field data and so on. And they are asking the questions that it should be. So this is the first topic. The second topic is construction surveys, which is 35%, very large percent. They are telling us what we're supposed to know, and so on. This is like a study guide for me. I need to cover these topics, or when you are studying, said, do I know anything? Well, for example, calculating and setting horizontal curve, radius, curve length, and tangent. Do you know that? If I know it, I'll say check mark. Calculating and setting vertical curve, high and low points, intermediate points. I don't know that. Oh, I need to study. So I put, oh, I don't need. So this is what they are going to test you. These areas they listed is called the test plan. California, if you go to California board, you will find the test plan. Okay. And this is, all my books based on the test plan, try to cover a little bit more. I always tell my students the first semester, I've been teaching for 30 years. 25 years, more than 32 years, 7 years in Las Cruces, New Mexico, when I did my PhD, and 25 years at Fresno State, CSU Fresno here. And I always tell the student the first day, shoot for the moon. And if you miss, you are going to land among the stars. Shoot for an A. And maybe one day you will sick, maybe the professor, he was tough on this exam and you have a bad luck. This A might go down to B. But if you are shooting from the beginning of the semester to get B or C, this B or C maybe go D or E or F, D or F. They don't have E by the way. Okay, sorry. So D or F. So this is why we need to prepare ourselves that I will be able to answer all the 55 questions. Nobody, I cannot, even myself, if I go and take the exam, I will not be able to solve the 55 questions in 2.5 hours. But at least to push as hard as we can to be ready to get the maximum number of questions correct so you can pass. And whatever passing score they decide is up to them. I don't care about how the skill they are using, what they are doing. As they let them decide whatever. Let us prepare ourselves, and the preparation that I'm always asking everybody, you need to understand the concept, because you will not go to the exam with all books available in the market and you open the exam and you will find the problem on the exam similar to any problem in the old books you are carrying with you. No, they are coming up with the new problems, but the concept is a concept. Horizontal curve is horizontal curve. Leveling is leveling. Staking is staking and so on. But if I understand the concept very well, it doesn't matter what problem they are going to get to me in the exam. Okay, so this is just introduction very quick, and we'll proceed. For example, earthwork quantities are usually calculated by the use of question number 1, mass diagram, Simpson's rule, a Presmodial formula, average in the area method. We should know what he's talking about here. You know, mass diagram, which I covered in chapter 8 of my book, is a relationship mass diagram. What is a mass diagram? Mass diagram is a tool that we use it in order to decide if the job is in cut or fill, and how much cut I need and how much fill I need. So they came up with this tool. A mass diagram is a graphical representation between a station, which is the x-axis or the abscissa, and the vertical is cumulative volume. It must be cumulative. Cumulative means additive. Cumulative volume. And they decided to put the cut on the top and the fill on the bottom, or this is a plus and this is minus. So they might give you a mass diagram and ask you what this mass diagram represent what, or whatever information he needs you to calculate from the mass diagram. Mass diagram, in order to plot it, I need volumes. So the earthwork quantities is an input to a mass diagram. So a mass diagram could be either a curve or a straight line. It could be something like this, where if I ended here, that means that cut is greater than fill because I ended along. So this is a typical mass diagram, maybe. So this before, or it could be in a shape of a curve. It is like this, and I ended somewhere here. This also a mass diagram where fill is greater than cut. But you might end it with a mass diagram where the fill and the cut are equal. It could be curved, it could be a straight line. As I told you, there is many ways, okay? And I ended somewhere here. This mass diagram, cut equals fill, balance job. So in order to construct the mass diagram, this is just illustration of mass diagrams, and we'll see some values. In order to do this, I need what? I need the earthwork. So the input for this, I need earthwork. Sorry for my Egyptian English. Sometimes I will be fine. I will be fine. You're not the first one, and you will not be the last one. I've been teaching for 30 years, and the first day of the school, Dr. Mansour, I told him, I'm sorry, this is Egyptian English. I will try to improve it as much as I can. You are very welcome to ask. I will not really be offended by stopping me and ask me any question. So the earthwork, so you need the volumes, the earthwork. So this is what earth quantities, earthwork or earth quantities. A Presmodial formula, average in the area. We use these two methods to calculate the volume. The volume, we're going to see it later on in chapter 8. Volume, we can calculate the volume using the average in the area. Average in the area. This is one method where we say that the volume is equal A1 plus A2 divided by 2 times L, and we use 27 to convert cubic feet to cubic yard. This is one method, but this method has a problem, or this approach of calculating the earthwork or the volume of earthwork, volume of soil, earth quantities or earthwork quantities. It has a problem that this method overestimates, and this is why the contractor, they like it. So they came up with another method called the Presmodial formula. Presmodial, B-R-I-S-M-O-D-I-A-L, Presmodial. Volume is equal in this curve based on the Presmodial formula is L over 6 times A1 plus 4 AM plus A2, and we'll see all these parameters later on. This is the middle area. This Prismodial formula is more accurate than this. A Prismodial is more accurate than this, but it needs more work. So those two methods listed in the question, yes, they can be used. So the answer is C and D. C is the Prismodial formula. The other one, the average. I can use either method to calculate the volume or the earthwork quantities. This is a V, the volume. But Simpson's rule is this. Simpson's rule uses it to calculate the area. And we're going to see it in chapter 8. So Simpson's rule, it is a method to calculate the area. It's not to calculate the volume. So this is out. It's called the process of elimination. Mass diagram is not mass diagram. In order to construct, I need this. So this is also out. Mass diagram is not a method to calculate the quantities. The quantities are required to construct the mass diagram. As I told you, the quantities, so it's not a method, okay, to calculate the, okay. So I left with two, and this is what I need to think. It's called the process of elimination, a process of elimination. I eliminate the answer does not make any sense because they are, but how you will know that? If you didn't study, you will not know the difference between this and this and this. But if you study and you know that the mass diagram is not a method to calculate the earthwork, Simpson's rule is a method to calculate the area, it's not the volume. So I left with two. At least I can narrow my choices. And if I don't know, and I wait until the last second or the last minute of the exam, I will pick one and pray to God. But it may be 50-50 in this case instead of 25%. But we need to prepare ourselves to select the correct answer. And the correct answer, because they give you 4 answers. And they know our mistakes. So they give us the answer such that it will match the mistake that we normally do. And that's why you hear the stories, oh, I went to the exam and I found all my answers are there. I think that's correct. But some of them are wrong because they know that mistakes that we do and they put these mistakes. So in every question, there is a keyword or keywords. Since based on my teaching experience, and I used to write questions for the board way back. So there are keywords. These keywords, look for it. In every question, there is a keyword or keywords that will tell you this is what they are looking for. Here, they are saying that earth quantities are usually, you'll find that the programs available in the market, they use the average in the area method. Usually, we do this in the office. We don't use a Prismodial because this is much easier, easy to formulate, easy to program. So we use it, and we can get rid of the drawbacks or the problem that we can modify or enhance our accuracy by reducing the distance between stations. So the word usually is telling me that which one is the most frequently used, which one is the most of the engineering. So this is the answer D. Say it again.
So it says average end area. Area is square units.
Yes.
Cubic units.
Yes.
So I picked that one only because I know you need area to solve volume.
That's correct.
But it doesn't make sense that it's just area that it mentioned. It's called average area.
This is called.
What it's called.
This is what my grandfather, they call it average in the area, and we are going to respect that. So basically, in the average in the area, what they do, okay, this is my original ground, OG. And this is my profile, the profile grade, the vertical alignment I developed. Here it is. Assuming that this is a profile grade. Okay, which is This is the vertical alignment. Vertical alignment. So we do have cut and fill. If you look to this, since this below the OG, so I have cut. This is fill. And this is cut. And finally, we ended with the area of fill here. But these are stations. We provide stations. A station is a distance, as we are going to see. So at any given station, I need to calculate the volume. Okay? So what the average in the area means that I will come along this and I see what is the area here. We'll call it A1. And at a distance L, we'll call it A2. This is the other area. And this is L. So the volume that we learned in high school, what's the volume? Volume, all the equations available in the market and all the equations available in surveying books, based on one equation. Volume is equal area times length, or area times depth. This is what we learned in school. So the volume, so the average in the area, say that take one area here and take another area at a distance L. Add them together and divide by 2. You take, this is the average, and you multiply it by the length. So I did not violate the concept of the volume, that the volume is equal area times length or area times depth. Okay, this is the concept of the average in the area method, as you are going to see in chapter 8. If you go to chapter 8 very quick, I'll show it to you and we'll go over this. Okay, so chapter 8, there is a table. Here it is. This table is given on page 183 of the textbook. The textbook, okay, if you have the textbook, Surveying for California BE, you will find in page 183, this is the average equation 8-15. A1 plus A2 divided by 2, L over 27. 27 just to convert the volume from cubic feet into cubic yard. They came up with the Prismodial, which is L over 6, A1, and we'll talk about this. So we need to decide very quick as far as, if you go to question number 2, okay, if you look to the, on a mass diagram curve, the low point on a loop indicates what? This is what I was telling you, mass diagram. A mass diagram is a graphical relationship between distance in a station and the cumulative. It must be cumulative, not the absolute volume, cumulative volume. The word cumulative means additive. Additive is not the absolute volume, and we're going to construct the mass diagram. Okay? We call this a loop. A loop means cut and fill. This is a loop from here to here up to this point. We call this a loop. A loop consists of cut and fill. Cut, positive slope. This is cut. And the fill is negative slope. So this is cut and this is fill. Any loop consists of cut and fill. So here we have this loop here. It has this point here. They agreed this point, we'll call it high point. So a loop, like this orange one here, from here to here is a loop. A loop consists of cut and fill. If it's curve, still, this is a low point. So when you have a high point, this high point indicates what? Indicates the change from cut to fill. But the low point, this here is negative slope, so it is fill. And this positive slope is cut. So the low point is indication from fill to cut. But the high point from cut to fill. We should know that after you practice and after you construct the mass diagram. So in this case, going back to the 4 possible answers. Okay, a low point from what? From fill. Okay, which is, the answer is, okay, that's correct. So this is the answer that you're supposed to pick. He throws something else, a change in the direction of hole, a change in the balance line, a change from cut to fill. As you can see here, by the way, answer C and answer D opposite to each other. Not necessarily the correct answer is among the two opposite answers. I don't like you to assume that. Sometimes yes. For example, this question here, question number 5, about the station rate of change. I have two opposite answers here, one positive, one negative. But the correct answer is B as in boy. So don't assume that the correct answer will be always among the two opposite answers. Like in our case here, I have C and D, they are opposite to each other. One from fill to cut, the other one cut to fill. And the correct answer is C, but don't always assume that. It might be, and they do this intentionally. Okay, so if you look to the question number 8, double meridian distances are used to do what? To calculate a closed areas of a figure, relocate meridian lines, relocate township lines, calculate baselines. This is called DMD. DMD, double meridian distance. And we are going to see it also in one of the chapters. What is DMD? Volumes, as I told you, but before I leave this page here, volume, we use average in the area method. We use the Prismodial method. And there is another method you are going to see. It's called the prism or pyramid/pyramid, the Egyptian pyramid. Here it is. And we are going to use another method. It's called the truncated cone method. Pyramid and the truncated cone method. On the exam, he will not tell you which method should be used. On the exam, he will tell you the volume is of the given, and he will let you to choose between the average in the area, a Prismodial formula, a prism or the pyramid, or a truncated cone. Or there is another method we are going to, it's called Borrow, B-A-R, Borrow, bit volume. So I have 1 and 2 and 3 and 4 and 5. They will tell you, okay, you are going to be a PE, you have to decide which method is the appropriate method to calculate based on the given information. They will never tell you use this specific method. They leave it up to you to decide which method is the appropriate one based on the given information, and which one is a more accurate one, which one is a more applicable one. So the area also is required to calculate the volume. So the area computations, they came up with area. Obviously, we have the basic shapes, We should know how to calculate the area of a circle, of a triangle, of a trapezoid, name it. All these shapes, we should know how to calculate that. Basic shapes. But they came up with additional methods for more complicated areas. For example, if you have a parcel, I have a piece of land like this, something like that, very odd shape. This is called a traverse. And I need to calculate the area of this. Of this traverse, if I know the dimensions, which it would be given to you, bearing and distance, and I need the area of this parcel here, this odd shape parcel. And sometimes they ask really tough questions, and I will go over one in just a minute. So the basic shapes, what is the area of a circle is by r square. What is the area of this 1/2 base times height? A trapezoid, it is if this is A and this is B and the height is h. I should, that's A plus B divided by 2 times H. So we should know all these, and all these things are given, by the way, in my book. All these things are given. Don't worry. Okay? I will assume that you know nothing about surveying, and I teach the class as if you know nothing. Like tomorrow, I will be teaching seismic using the new code. I teach it also assume that nobody took a seismic class in the undergraduate course, because I should assume that. So area, in addition to the basic shapes, they came up with 2 methods. One of them is called DMD, double meridian distance, which is the one is asking you a question number 3, double meridian distances. And the other one is called coordinates. Coordinates. And we need to know how to do that. How to calculate it using coordinates or DMD. DMD is a little bit tough, takes time, but coordinates is much easier. But you should know what we are using these for. So for example, here, question number 3, excuse me, double meridian distances are used to calculate the area of a closed figure. This is answer A. Yes, that's it. Question number 4, and there is other 2 questions also. This is related to what is known as the US PLS. I will skip it until we cover this in chapter 14. I will cover it in half an hour, and it will be very easy. The township and the section and range and all these things, and the legal description, I will cover this. Okay. Question number 6. Errors. Errors are very, very important. And computations. Constant or systematic errors are compensating errors, accidental errors, personal errors, or cumulative errors. You will find in chapter 2 of my book and chapter 4, we're talking about types of errors. Errors, any surveying measurement, it does have some kind of error. When we survey, because we are human and we are using equipment, and there are some environmental factors will affect the readings that we take. So this is why we have some kind of ranges or standards. So any surveying measurement I do or you do, it does have kind of errors. When we talk about errors in surveying, there are 2 things I need you to differentiate between them. Sources of errors and types of errors. Types. Sources, there are instrumental errors, and we use I for instrumental errors. I will show you a table in just a second in my book. And personal errors, we use P. And the environmental errors, we use E for environmental. Temperature and magnetism. Those are the sources. The sources. So be careful what he's asking. Asking for type or sources. If you look to the book, and when we hit this chapter 2, for example, you will find there is a table I provided, I believe here it is. Table 2-1. It's talking about the types of errors. Types. So, and this is the one here. Types. Your types, we're talking about the systematic and the random. And I will go over this table. But going back to the sources, I discussed this in chapter 4. And it does have a table also. if I remember correctly, let me see if I can locate it very quick, about the sources of errors, because we need to be aware of that. Here it is on page 91. Sources of error, sources on page 91 of the textbook. You'll find instrumental errors, I, natural error, and personal. Let's make it natural instead of environmental to be okay. Natural to be consistent. Okay. Natural error. And we'll talk about this. Here, the question number 6 of this quiz is talking about what? Types or sources? Types, exactly. So if I look to the table in chapter 2, the types, systematic errors and random errors. Systematic errors, they conform to mathematical and physical laws. Their magnitude may be constant or variable. They can be computed and their effect can be canceled out. And also they are known as a cumulative errors, cumulative. So systematic cumulative because they are additive. Okay, I have a tape and this tape was made short of a couple inches. This is because every measurement I am suffering 2 inches short because the tape was manufactured wrong. This is called systematic error. It's happening with the same magnitude and the same sign every time I do that. Okay. But if you look to the other one, random, they are following the law of probability. The magnitude and sign is a matter of chance because random, they are random, but they are called also accidental errors or compensating errors. You see the table over there and on page 56. So the different name, random is called also accidental, it's called compensating. But the systematic they call cumulative. So if I know that, and you're supposed to know this by heart, if you know that, so systematic errors, what is the answer? D as in David or doctor, is cumulative errors.
What page was that on, sorry?
Do you have the textbook?
Yeah.
It is on page 56.
Yeah.
Oh, no problem, no problem. Page 56. Okay. If you look to question number 7, for example, distance between 2 points in surveying means what? Number 7. Okay. Which is the answer is C. Yeah, you are right. Horizontal distance. Number 8. Topographic surveys are surveys for what? For determining land boundaries and areas, determining the shape of the bottom of rivers, lake, and harbors, locating objects below the Earth's surface, or determine the shape of the Earth, of the ground, and the location of natural artificial features on it. Topo maps, topographic maps. We have a chapter 13. We'll talk about topo maps, topographic maps, how they do it. And this is the definition of topo maps or topographic surveys in general. Topographic surveys, so determining the shape of the surface of the Earth and so on. So if you flip the page, you will find this another question. This is also related to USPLS. I will skip that PLS. I will leave this right now. And the following question also, USPLS, United States Public Land Survey. But if you look question number 11, I don't know if you answered correctly or not. In order to solve this question, you need to have some kind of drawing or illustration. You cannot really, you have to draw something to know exactly what datum he's talking about. Because he gave you the national or the North American vertical datum. He gave you the city datum. So you have some kind of references to certain datums. And I don't know if you guessed it right, that's a blessing from God. What answer did you guess for number 11? Okay, no, the answer is A. Okay, and we'll talk about this. This is leveling, and we'll talk about this chapter 5. And finally, number 12. Sure. Which of the following are commonly used method for performing topographic survey, topo survey, topographic surveys? We're going to talk about different types of surveys and which one can be done legally, or which one legally you can perform as a civil engineer. Can you do photogrammetry surveys? Yes. Yeah. Can you use the total station? Yeah. Yes. Can you use a transit and stadia? Yes. Can you use a transit and tape? Yeah. Yes. Can you do global positioning system? Yeah. Yes. Can you do this? Meets and bounds. Okay.
I think so, but because that's meets and bounds is distance enabled, so technically, yeah, it's transit, right? Or meets and bounds. Oh, I'm sorry, that's a description of this bearings and distances, isn't it?
Okay.
Yeah.
Okay.
Sure.
Sure, yes or no?
I say yes.
That means which answer is that?
So that would be, oh, okay. That would be D.
So the answer is D, and this is the correct answer.
Is it?
Yes. Because meets and bounds, okay, okay. Let us look to the references. Since the word meets and bounds, okay. As you know, the California board, they have a test plan, as I mentioned, and they have also, they give you a list of references. If you go to their website, they give you how many references they listed nowadays. Did you get a chance to check the number of references? This is the latest list, and always check the California board. They give you 9 books listed as list of references. When you go to California board, or the easiest way, by the way, you can go to my website. I believe my webmaster put a link. Let me see if it's still there or not. Let me get my cursor here, and I will go home. And if I go down all the way to here, here it is, this California board. And I will go to exams, and I will go to examination reference and test plan, this one here. And I will go for surveying, a civil seismic list of reference. Here it is. So you'll find there are a list of references. They provide the California board, and always check this from time to time. I checked it. I check it from time to time, but I highly recommend you to check to see if there's any change or not. Under surveying, they have general reference, which is the Professional Engineers Act and board rules. You can download these things. But for the surveying exam, as you can see, they have this book. I don't know why they listed. And this book, this gentleman, he passed away, Como, Paul Como, yes. He is from Clovis. You know that? Yeah, he passed away a few years ago. And another book, this is my professor, by the way, Professor Brinker. This is the one who taught me surveying in Las Cruces, New Mexico. He has about 6 books about surveying. Okay, so there is a list of references. And this list of references, if you, and the Subdivision Map Act, and there is one specific one, which is this one here. Definitions of surveying and associated terms. And this is the book I'm going to show to you on the screen, which I highly recommend you to buy it today before tomorrow. Okay, this is a small book. I need you to order it because we don't provide any, provide only 4 books, but you need to purchase this. This, it does have definitions of surveying and associated terms. It's available, I don't know for how much right now, but you might have 1 minute left, and probably you don't know what does it mean, this word, meets and bounds. What does it mean? I never heard about that. You may be able to open this book and look to the what does it mean, meets and bounds, and probably you can very quick, you can be able to answer the question related. So I highly recommend you to get this book. Sorry, I seem that it is listed on the website and is given in my books. Everything is given in my books. Here it is. Can you open any book at the beginning of the book? In any of my books, you will find all this list of references and the test plan, everything I gave you. For example, if you go to this, let's go to the practice exam. At least we are using the same book. Do you have the practice exam book with you? No, you have it. You have the book. Okay, just at least to be on the same page. Okay, so if you go to the under board registration, okay, of registration, page VII numeral, okay, Roman numeral, okay. Did you find it? Page VII reference.
Yes.
Okay, so you'll find those are the 9 references available on the website for. So here it is. So the book I am talking about, this one here, the surveying with, okay, the definitions. Here it is. This is a book that I say that this is number 1. You have to purchase this one, because I do include in my summary book, I have a very comprehensive list of definitions and associated terms, but I cannot guarantee that I will match this. I cannot match this. This is a Bible, okay? It is published by the Congress, okay, by the American Congress on Surveying and Mapping. So one definition, it can be best versus fair. Okay, no, here it is on the board, on the California one. So you need to get this one. And if you look to the other references, for example, they list the Michael Lindbergh book, the Serum book, the one I wrote 5 chapters for him, Serum. Okay, it has only 1 chapter at the end. It has about surveying. I will not buy this. This personally, I'm not against any him, because I wrote 5 chapters in his book, and they are still there. Michael Lindbergh is, but I believe they are not sufficient at all. Como book also, don't buy it at all. I use it once and I never use it again. It's not sufficient at all, and it will not help you at all. Okay, I still have, this is a textbook, and 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 this is a textbook. So among these textbooks, these are textbooks in school. Okay, I use all of them. Okay, when I was teaching surveying back in Las Cruces, New Mexico, we have a very nice department. It's called civil engineering. Geometric surveying. Okay. All what I recommend personally, I don't have any. This one here is too much. This is this they call the Bible of surveying, which is surveying theory and the practice by. Here it is. We teach this in 2 semesters. Here it is. This thick book, very thick book, surveying theory and the practice. A very thick book. They cover it, okay, in the surveying department. It does have this called the Bible of surveying. It does have. I don't like to say everything because I don't know everything in this book, but they call it the Bible of surveying. But it's too much. It's too much. Too much, and you don't have time when you are going to study this. Okay, this is, I need to take only 1 book. If you have your school book, if you still have your surveying book, I don't know which book did you use, but if you can locate it, I will be the best thing that I will take me to the exam. I can remember by who, I have no idea. Whatever book. If you cannot locate your book, so this is too much. This is too much. I will not really. Okay. Among these, the simplest one I see, it is surveying with construction applications, because the exam nowadays, they focus on construction. This is the book. This, here it is. Surveying with construction applications. This is the 8th edition. I don't know which edition they have. Oh, this is the 8th. So this is the latest one they are using, because I have all editions. This book, it's, first of all, it's cheap. You can get it for about $60 or $70 by Kavanagh, Barry Kavanagh. He was the first author, and after that he had another author. But if you have the first edition, or the second, or the third, or the fourth, or the fifth, or the sixth, all of them will work. Believe me, I have all the editions, but just a matter of to make more money, and they come up with a little bit of little tiny here or there. But if you are able to locate the 8th edition, just to stick with this, I will recommend this book. The beauty about this book, it does have a lot of illustrations, a lot of drawings, and a lot of illustrations. It's still a textbook. Okay. So, so I would say that this is the first, this is my second book that I will buy, unless if you have your own textbook, I have no problem with that. If you cannot locate it, buy this one. If this is too expensive, go to the 7th edition. Do I have the 7th edition? No, this is the 6th edition. I believe this is the 6th. Yeah, this is the 6th edition by the same author, Serial Construction Application. Okay. Uh, as I told you, that essentially the same. The first edition, like the 8th edition, with some kind of modification and it changes here and there. So there are many, many books available in the market. And I would say that we don't like you because it's not a matter of buying books. No, only one textbook. I need to take it to the exam. One textbook. And this for sure, which is the definitions of surveying and associate terms, the blue book, the one I showed you. Okay, this one here. This I consider this is a must. Okay, and this you can download from the web. This download, I need you to download this. Download the Subdivision Map Act. This is for free. So basically, this is the third one. So 3 references beside my books, and this is what I heard from the engineers who used my books and they passed. They told me that this was sufficient. But I cannot make this claim because legally I cannot say that my books are sufficient or are. You are very welcome to take in any of these. If you like to buy all of them, take all of them. You are very welcome. But you don't have time even to, believe me. As I told you, you need to solve at least 20, 25, 30 questions. You need to prepare to master the subject. You know exactly what they are talking about and solve problems. I believe the problem that in my books, plus any additional problems that you have from another source, I have no problem with that. Give it to me. If you have any problem solving any of them, I will help you to solve it. But I will start what we have in our hands, the 497 problems. If you solve them 2 or 3 times, I believe, but you understand the concept. Is not solve it because I did it that way. No, you have to understand why we did it that way. Because the problems are so tricky. It's not really like, okay, here it is. No, they are so tricky. So this is what I would like to say. So let's take a few minutes to break and come back and we'll continue our discussion after, okay? Stretch your back to get some fresh air or a fresh coffee or not fresh donut. Don't eat donut now because it's too late. It's too late. It's too late. Okay, so right now it's 5:45. So 5:55, I will join you guys. Okay, thank you. Okay, welcome back, everybody. Okay, so after this short break, so after this introduction, let's go to the business, and the business is let me ask you: are you looking for the PLS, or you are talking about for the surveying for the PE
No,
exam?
I'm taking the PLS, and Nick said that this would be a great review course for it. And then if I need to take another, I'll probably end up going to Sacramento. I looked online, the closest one is Sacramento. I don't know. I think CLSA might have something, but I didn't see anything here.
Yeah, Como, his son was teaching. He used to teach this class.
Oh, really?
In South. I don't know if I don't know I can't remember what's his name. But that's fine. That's fine. If anything I can help you, please let me know.
Nick,
But this is
yeah, Nick highly recommended this class.
Who is Nick?
I'm sorry, Narinder.
Uh-huh.
Yeah, Narinder Sahoda.
Oh, yeah.
He's the one that recommended it.
Okay, thank you. Yeah. The one who has a business in Selma?
Yes.
Okay, okay, I know. Yeah, he took a class with me.
He recommended class.
Yeah. Okay, but it's not sufficient for the PLS.
Right, I didn't think so.
Okay, just to make sure that.
It's a good starter.
That's good. That's good. Okay, just to make sure that we're on the same page. I don't like to. Okay. Okay. Okay, good. Let's go. Keep going. Okay. Okay. So so if we start with the textbook, which is the thick book. This here is called, no, it's called surveying for, this is a textbook. Let us number them. If you look to the books, at least I can like for a transportation group, I number the books to them, at least they can.
Oh, that's for PE.
Okay.
That's something
else. Do you have this book, The Surveying for California BE Civil License? Yeah, this is a textbook. Yeah. This is a textbook. This book number 1. Yeah. Let me get the camera here at least to be on the same page. Okay, here it is. So this book number 1. This book consists of 15 chapters. Okay, and this is called the textbook. So this is a textbook. Okay, and this will prepare you. The other books are problems and the questions and summaries, but this is the textbook. It has the theory. Here I cover the theory, plus, okay, the additional problems, which is I have about 247 problems. Okay, in this book. Okay, so the first chapter, if we start with the first chapter, which is has summary at the beginning also, but the first chapter is an easy one, okay, which is called Introduction and the California Special Surveying Exam. So this is an easy chapter. Sometimes I assign it as a reading assignment. Reading. Okay. So by the way, the packet I gave you, I give those who are here, I give you this packet. I have quizzes. It does have the solutions. Also, you'll find the solutions, by the way. Okay, they are in the same packet, just in case if you'd like to review anything. And I will go over these problems again when we hit. So what is the first chapter here is talking about? The introduction and the California surveying, special surveying exam. What's the definition of surveying? Surveying in general, as defined in chapter 1 on page 42 of the textbook, page 42. Definition of surveying is the art, science, and technology of making measurements. What we are really measuring? We are measuring points to determine the relative position of these points, okay, with respect to each other. So when we are talking about measurements, we are talking about measurements of what? We are measuring distances, we are measuring angles. So surveying as a science is locating points above and below OG. This is the OG. So I need to know this point here, point A, where it is located horizontally and vertically. We call it H and V. H for horizontal datum, which is basically coordinates and distances. The horizontal datum that it was used in the past, by the way, is called NAD 1927, North American Datum 27. This is gone. We are no longer using the NAD 27 for the horizontal control. Right now, we are using NAD, okay, of the 1983. This is a current datum that we are using, current datum. Horizontal control, it should be based on the 1983. The vertical, which is elevations. So vertical, H for horizontal control, which is coordinates and distances. Distances and coordinates. Based on the H, the horizontal. Vertical, this is the vertical control. Vertical control. In the past, we used to have 1929 National Geodetic Vertical Datum. This was the old datum, but this datum is gone. This is old. And this is also 1927 is old. They are no longer using this datum because they update the reference points and coordinates and all these things, the shape of the earth and the mean sea level, all these things are changing from time to time. So right now we are no longer using 1929. We are using right now the 1988, the National Geodetic Vertical Datum. This is now. So when you are reading a map, either a topo map or USGS map, USGS, by the way, they have USGS.gov. They have a lot of maps. The United States Geological Survey, if you go to this web, www.usgs.gov, United States Geological Survey, they have a lot of information about seismic and surveying, okay? And you can get a lot of maps and a lot of... So when you read a map, either a topo map or quad map, there is something called the quad map, quad map or topo map, topographic map. When you read these maps, you should know what datum is used to establish these points. Because it's a common mistake that we don't know the datum. And there are some mistakes in construction. It's related to different datums. I use the datum and use different datum, and we are neat. So there is, I was involved in one case, bridge was short of 6 inches because of that, because different datums, and it's a human, we do mistakes. So yeah, it's a huge, obviously. So the datums are very, very important to know which datum we're talking about. So going back to the definition of surveying, that we are determining what we are measuring. We are measuring distances, horizontal and slope distances. We are measuring angles, vertical and horizontal angles. We are determining the elevation, which is the vertical distance between points. And this figure here, which is in figure 1.1, I'm defining these distances. What is a vertical distance? I have a point A and point B. So this is a vertical distance. The horizontal distance is measured like this. The slope distance is the slope distance based on the slope, whatever the slope is. So, and we have the angle, the slope angle. Okay. So this is what we are really measuring, okay, in surveying. Leveling, we are going to cover this in chapter 5. We have a level, we have a tripod, and and we have a rod, a leveling rod, and I have some rods here, I'll show it to you. Okay. And basically we level this instrument and take a reading and move the same rod to another point and take another reading. The difference between these two readings is giving me something. It's giving me the difference in elevation between these 2 points. But if I know a benchmark here, a benchmark, and I know the elevation here. We call this backside, and we call this foresight, BS and FS. And always the backside is the reading of a point of known elevation. If I know this benchmark and the elevation here is 2051.6, for example, or 2050.6, so this elevation is known to me. So the reading, the rod reading, we call it RR, by the way, the rod reading, okay? RR, rod reading. So it is a backside, and the reading at the point of unknown elevation is called the foresight, FS, and we're going to do this. So differential leveling is very, very important. Differential leveling, and we're going to see this. Okay. Horizontal and vertical angles. If you look to this diagram here, the one I colored here, when you are sweeping an angle in a horizontal plane, we call it H, horizontal angle. I sweep an angle, horizontal angle between, okay, two lines. Like this line here and this line here, this is called H. But if you go vertically up and down, you have a vertical angle and vertical angle. And this illustration here is, and I define what is a horizontal angle and what's a vertical angle. A horizontal angle is measured in a plane that is horizontal at the point of measurement, horizontal level, horizontal plane. But when I go up and down, this is a vertical plane. So we need to know the difference between a horizontal angle and a vertical angle. And we're going to see in chapter 6, at the end of chapter 6, different types of vertical angles. And we're going to talk about types of surveying. Types of surveying. In January 1st, 1982, something major happened. In January 1st, 1982, our professional land surveyors were upset with civil engineers, and they said that a civil engineer should not practice the same practice that we do. So in January 1st, 1982, 1982, they are saying that we have a PLS and we have a PE. Okay. PLS, he is entitled to do all surveys, or surveying measurements, or all types of surveys, because he's registered as a PLS, professional land surveyors. But the PE, the civil PE, to be more specific, PE7, is not any PE, it must be PE7. They limit the types of surveying that can be done after January 1st, 1982. But before that, they are equal as far as doing the types of surveying, as far as doing the tasks. So when we talk about types of surveys here, which I will go over them from the textbook on page 43, the first type is a control surveys. What is the purpose of the control surveys? Is to establish a network of horizontal and vertical monuments. We need to establish monuments, and I will show you what's a survey monument, that serve as a reference for network for initiating other surveys. As a civil engineer after January 1st, 1982, can you do that? The answer is no. You are not, we are not allowed to do any control surveys after January 1st, 1982 at all, okay? Any control surveys, any property legal description, no. Any appraisal maps, no. Name it. I will go over a list of things that we are not supposed to do, and I put it in a summary, by the way. I put it in a form of a table, because sometimes the engineers, I have a book, it's called Comprehensive Summary of Equations. It is also, it goes as a companion to this book, and I have some additional information. And for example, what a civil engineer can do, I put it here in a table. Here it is. For example, this is a table that before 1/1/1982 PE can do any kinds of surveying. Before 1/1, but after, no. For example, control surveys, no. Okay, land boundary, no. Okay, condominium surveying, no. Solar surveying, no. So we'll talk about these types of surveying. So on the exam, they might ask what you can do and what you cannot do. But basically, anything as far as related to the legal description, as far as the boundary, legal description for a property, okay, setting the control, no, and so on. We'll talk about all these things. So control surveys, basically you establish survey monuments to establish horizontal and vertical control to be used for another surveying, okay, work. Topo surveying, topographic surveys. Topographic surveys. What is the topo surveys? Okay, topographic surveys basically determining the location of the natural and artificial feature, okay, and the elevations on a map. So you have a piece of land or a lot, and you ask me, Mr. Mansour, go ahead and provide me a topo map for this area. I will go with my crew and I will determine the elevations for certain points. Any feature like a tree, I have to show it. Any structure, I have to show it. So all natural and man-made features should be shown on a topo map, topographic. We call it topo map for abbreviation. Topo map, contour lines, and so on. And we have to put the datum here and so on. So a topographic map is a topo map is a map showing the artificial and man-made features as if you are flying over it and see it. Okay. And there are two methods to do that. Topo maps nowadays, and with the technology, we have two major methods. The traditional or conventional surveys. Traditional, what's traditional? Traditional means a surveying crew will go, they have a tripod or a total station, and take measurements. If you have a level, if you don't have a total station, you can use a level, theodolite, or a transit, any kind of surveying equipment to get horizontal and vertical location of what. Total station obviously is the best because it does have everything. So this is called the traditional surveying, traditional surveying, which is surveying equipment and prism or rod and the crew. It's called traditional surveying. The other method that nowadays it has more than one technique is called aerial photographs or photogrammetry. They go and they fly the area, they take pictures, and knowing these or taking these pictures and using photogrammetry, and we are going to see this in chapter 13, photogrammetry, how they do that, to generate the map, okay, or the topo map using photogrammetry. Each one of these methods, it has advantages and disadvantages. So if you would like me to put in a table form, always I prefer tables. So this is a traditional method, traditional, and this is the aerial where we fly. And if you look to the accuracy, which one is more accurate, by the way? Accuracy. Relative. Which one is more accurate, the traditional survey or the aerial survey? This is more accurate. You are completely right. This is more accurate. And this is less accurate. Okay? Because physically, you are putting the rod or the prism and you take an actual measurement. But the area you fly and they use the photogrammetry technique and they have an error, and we are going to talk about errors in chapter 13. This is chapter 13 when we're talking about photogrammetry. But traditional, we're going to talk about in chapter 4 and chapter 5 of my book. So this is more accurate than this. And this is why sometimes we insist for a ground surveying, called the ground surveying, which is the traditional. Traditional means the ground surveying. Some surveyors, they try to prefer to use a ground surveying, but we call it traditional. So the accuracy, What about speed? Obviously, the aerial is faster and this is slower. I can fly a job, 10-mile job. They can fly it in 1 day with the plane, and I requested that. Some jobs I have, and I need aerial, and they cannot really get it fast for me using the traditional. So the photogrammetry department, they hire a company and they fly it and they give the maps and give me them. So this is much, much faster. This lower cost. Normally, this is cost more, by the way, because they have a surveying crew and a team, or maybe more than one crew. So generally speaking, this is, I doubt they will ask you that, but generally speaking, the traditional, it costs more, by the way. Most important thing is accessibility. Accessibility. Obviously, if you ask me to go ahead and survey a grapevine area over there in the mountain, it will be very difficult for me and my crew to go and survey. They would like to widen I-5 and they need surveying, okay, for mountain areas. It will be difficult. If I go, for example, I have a project over California Aqueduct and they have waterway. Yes, we have boats and we can survey using boats, but accessibility. Obviously, tradition is less accessible, less. This is more accessibility, more. So I need you to know the difference between the two methods. For the topo maps, this to generate a topo map, topo, or topographic maps. So, and they try to draw a picture or draw a figure, because every time you draw a figure or a picture is going to be very. So this chapter is talking about these types of surveying. So this is the topographic, okay, land boundary and cadastral survey. This will establish the property lines. Anything property lines or legal description, legally we cannot do it after those who register after January 1st, 1982. So this is the type of surveying that if you flip the page, we'll talk about the hydrographic surveys. What is hydrographic survey? Hydrographic survey defines shores and depths of lakes, streams, oceans, reservoir, and so on. Sea surveying, by the way, is associated with this when we need to determine the elevations of the bottom of a river or a lake. So they call it a hydrographic survey. Legally, okay, you can do it as long as the control has been set for you. But if the control is not set, we cannot do it as a PE7 register after January 1st, 19. But generally speaking, even if the control is done, and this is what we do, by the way, sometimes in real life, if you are hired me or you are asking me, you hired me to do a topo map for this area, and I don't have any control nearby, legally I can establish a control. I can put steel pipe here or a pipe, and I assume this my control. It's called temporary control. I will assume the elevation to be 0, 0, and the distance will be 0, 0. And all the points here will be in reference to this pipe. And after I finished all these things, I will establish the elevation and the course of this point by another benchmark somewhere here. I will hire somebody to do this for me, so I can adjust my elevations, and this is based on that. So you can put a temporary benchmark, fictitious benchmark, temporary, and we do this a lot. I used to go and do surveying, and after that, I ask our surveyors to go and establish a control for this point, and they adjust my elevations based on that. So I'm using this. This elevation, instead of 0, 0, I call it 100. And coordinates, I will use 1,000 and 1,000. And they take all my measurement with respect to this. But in reality, this is not 1,000 and 1,000 and 100. I will ask a PLS, can you establish the control for this point, such that I get the true elevation and the true coordinates, and after that, I adjust all my measurements with respect to this. So it's called temporary benchmark. So we can do that. We can do that, okay, and this is acceptable also. Another kind of surveys that we do is called route surveys. Route surveys, and this number 5, that are made for design of highways and streets and railroads and pipelines and so on. It's called route surveys. We do that. Construction surveys is very important. where you provide the elevations and the grid lines and so on. We can do that. As-built surveys. What's as-built surveys? After we finish the job, after the construction is completely done and the contractor is ready to leave, we do another survey at the end of the completion of the job. We call it as-built. Okay, and we do that such that to establish the final elevations and distances on the plans. Because if you have a CCO, if you have a change order, and we change something, so the designer designed something, and contractor or maybe the RE, the resident engineer, decided to have something different or enhance the design or change the design. So the as-built is determine the precise final locations. After all the CCOs are done and after the changes has been made, so we take this as built, we store it such that if another engineer comes and he's doing job and within this area, he knows where everything are located horizontally and vertically. It's called as-built survey. Sometimes we call it, by the way, final surveys. Final surveys. It's another term, and you will see this in one of the questions. Another type of survey is called mine surveys. This is to perform below the ground for tunneling and the other associated mining operations. It's called mine surveys. And you remember the story about this baby Jessica. It was in Texas. She trapped in one of the oil wells. And in order to reach her, they drill another shaft next to her and they do horizontally. So it was a story. It was even they named, okay, one of the oil, okay, rich guys in Texas, okay, he named an oil, okay, well, Jessica after her. She trapped in one well and they were able to go and dig in and so on. And mining people, the people trapped in mines, would drill a shaft and go horizontally, vertically shaft and horizontally. This is called mine. We need to know exactly where they are located. So this is called mine surveys. Solar surveys. Okay, the Egyptian used it way back in order to determine the movement of the sun and so on. So map property boundaries, solar axis, and so on. Condominium surveys. What's condominium survey? The word condominium, by the way, I explained it here, means ownership. Okay, so it is Roman law. Okay, it came condominium. Obviously, this is establishing the property of a specific person. Legally, we cannot do that because it does have the legal description of the property, and any legal description, a civil engineer after January 1st, he cannot do that. So we need to know these types of surveys and who is allowed to do and who is not. Another area, I skip the rest because some stuff you can read it on your own. What is the difference between a plane survey and the geodetic survey? We need to know that a plane survey, this is, we are assuming that the earth is flat. And this is suitable for small areas and short lines. So we're assuming the earth is flat. We are not taking into consideration the curvature, but there will be something, we are going to talk about it in chapter 5. It's called C plus R, curvature and refraction, C plus R. So the earth is not flat. Okay, the earth has a certain radius, and we're going to see the radius and so on. But for small lines and the small areas, we are using a plane surveying. So the plane surveying is acceptable, small areas and small or short lines. But here the word except leveling, by the way, when we do leveling, the curvature and the refraction is taken into consideration. When I put my instrument here like this, and I put the rod, okay, so basically the curvature effect is here. If I draw a horizontal line here, so this is the effect of the curvature. So whatever reading I'm taking here, it will take into consideration this. But if I take my rod and put it at a different point B, and we normally keep the back side and the foresight, this is to be equal. So I will do this. You will find that I added this distance here, but I will subtract it here, so they will cancel each other. So the effect of the C plus R, as long as you keep this distance, if this is X, it must be this X. So 200 feet here, 200 feet here. So if you keep the distances, it's called the back. This is called, if this is the back side and this is the foresight. So basically, if you keep the backside distance and the force is equal, so the error due to this will be canceled because it will be added here to the backside reading. After that, you add it here to get the HI, which is the height of the instrument. And after that, when you subtract this, so the force side, so basically you added something and you subtract something. If these two distances are equal, so the error will be added, subtract. So as we did nothing. Okay. So in this case, this is why we are using except leveling, because the leveling, if you keep the both distances are equal, the error will be canceled out. But when we do, and this is what the PLS they are using, here it is, PLS, they are using this to establish control. They have to take the curvature into account and the refraction, and they make a correction because they are going to establish a monument. This monument is used by another engineers like me, okay, or other engineers to take leveling or take measurements. So it must be very, so geodetic surveys, the curved surface of the earth is considered by performing, okay, the competition on a sphere. Okay, so you have to take, and this is applicable to large areas, and we use it for control. It must be okay. If you flip the page, you will find that some kind of leveling equipment and rod. Some also what is the horizontal distance and vertical distance, vertical angle, and what is the zenith angle. Surveying also could be classified as ground surveys, aerial surveying, and satellite surveys. Okay, ground, as I told you, this is the traditional one. Ground means the traditional survey or a ground survey. Aerial, okay, like photogrammetry, and satellite nowadays, GPS and LIDAR and all different techniques right now they are using, very fancy. Okay, but the GPS is a famous one for all of us. Types of maps. Types of maps. When we perform or when we do maps, and also I provided in my summary book here what maps that can be done by an engineer. We prepare maps, a lot of maps. What is a right-of-way map? A right-of-way map, okay, which is the first map at the bottom. What is a right-of-way? A right-of-way map is a map showing the existing right-of-way and what is the required for future right-of-way. Let me use a highway or streets or freeways, any kind of this. Let's assume that here it is, my highway is here. And let's assume it's access control, mean that I have fence. But we decided to widen the road. So I need to buy this land here. So this is called existing right-of-way. Right-of-way, RW. There is a lot of abbreviations, by the way, in chapter 12 of my book. You will find these abbreviations, and I will remind you with every abbreviation. RW stands for right-of-way. Right-of-way. And we need to widen the facility. So as a designer, and the engineer responsible for that, to decide how much additional land or how much I need to buy. For example, we are widening this side. So as an engineer, you draw the existing right-of-way, and this is called the proposed right-of-way, a proposed right-of-way. And you, any program available in the market, we use many of them to determine who is the owner of this. We don't have to get the title report. The title report, the PLS, they do that. So who is the owner? This is Mr. Mansour, and this is Joe. So we're saying that we are taking this area from Mr. Joe, we are taking this area from Mr. Mansour. This is what we, so this is called right-of-way map, right-of-way map, right-of-way map. A map showing the right-of-way needed for a future job. Okay, if there is a shopping center, here it is, a shopping center, not necessarily a shopping center. And the owner of the shopping center decided to make expansion or to add in more, so he's determining how much right-of-way is needed to build additional stores that he's looking for. So this is called right-of-way map. A map, let's read it together. A map, okay, showing the parcels and the area that will be needed for the purpose. That can a civil engineer register after 1/1/1982 do it? Yes, the answer is yes. You can prepare the right-of-way map. Okay. Topographic map, yes, for sure. which is a map that represent all the.
I got a question.
Yes.
Are they able to sign the new legal descriptions that are set for that right away? Maybe? Engineers sign the.
No, it's coming. It's coming in the appraisal map. There is another map. It's called appraisal map. It's coming. No, the appraisal maps. It must be prepared by PLS. We cannot prepare it after January 1st. Just a general, this is what we prepare. We are preparing, okay, what I need, that's it. That's it. I need to widen the road. Okay, the area needed, exactly. Okay. The other one is called record map after the appraisal map. You will see it. Okay, so we don't have, okay. So, okay. After that, we have the appraisal map. Here it is. So I will send this map to PLS, to the surveying department. They get the title reports. The title reports, it costs about, I don't know how much right now, title reports. I don't know. Right now, you can get the title report of your house, okay? You can get it very easy from any one of these title companies, okay? A title report is a report showing the legal description of the property. It does, if it does have any easements or not, the history of this, it does have everything. The title report describe the property, and our BLS, our professional land surveys, they are going to prepare a map. It's called appraisal map. This is called appraisal map. Appraisal map has the legal description of a parcel involved. So they draw the bars exactly as described in the title report, and they send it to us as engineers to review it one more time. Is this is the area, Mr. Masood, that you need? I said yes. So right now they take the appraisal map and they approach the owner, Mr. Joe. We're going to widen the highway. We're going to widen the shopping center. And the owner of this, he would like to purchase this land from you. This is on the appraisal map. Appraisal has a legal description exactly. Where is our right of way? And where is the proposed right of way? And where are the property lines of Mr. Joe, based on the title report? It's drawn exactly. And he put his stamp on it, PLS. The negotiation between the owner of this property or this highway or the mall, whatever it is, they negotiate with Mr. Joe, but Mr. Joe said that, no, I'm not going to give it all this to you guys because my grandfather was buried here long ago, and I don't like to give this because I believe this area is very important. He used to sit here, my grandfather, and drink tea with him, so I don't like to sell it to you. So they will come back to design. Design, can you live with everything except this corner? Can you modify your design? Sometimes we say yes, sometimes we say no. It depends really. So let's assume after negotiation back and forth, Joe accepted to sell this land to us, to the highway, for example. If he refused to sell it, he can say no. I'm not going to give it to you. Okay? And it did happen many times. The owner said, no, I'm not going to give you my land. So we do have what is known as a resolution of necessity. Which is about the public domain. We'll go to a hearing. We'll go to level 1, level 2, and go to the CTC, California Transportation Commission. And there's a longer process nobody will ask you about, but I can explain. I went through this more than once, where we get the owner and his lawyers and his engineers and negotiate with them. And if they insist, we'll go to the to Sacramento and go to the California Transportation Commission, and they will decide if this land should be taken away from him or not. If they issue a resolution of necessity, I go to the court and get what's called order of position, because CTC has no legal power. So I take the decision of the California Transportation Commission and go to the court. I went to Bakersfield more than once. They give us something called order of position. Order of position means that they are telling the owner, Mr. Joe, you have order. It's called order of position. Order of position. Yes. Yes, he has to give us a land. Okay, and if he refuses, we take the police and go and take the land. Never haven't they give it. The moment that order of position, we take it. The money issue, we don't involve in it, because Mr. Joe, he said that you give me $10,000 for this land, and this land 20,000. I told him that we are not negotiating. Okay, the price. If you don't like the price, go to the court. Legally, you can go to the court, and let's go to a jury, and they will say, Caltrans offer, get your appraisal. Let your appraisal. We have our own appraisal. He appraised it for $10,000. He will get his appraisal of $20,000. And we disagree. So what we go to the court, and we have a jury, and the jury will say probably in the middle 15,000. We give 15,000 and we settle. Or sometimes we settle before we go to court. But this is an issue that to save time and to save money. But we get the land to build the property first, the highway, because the highway is required for the public domain. It's called public domain. Public domain, and some people try to cancel the public domain, but anyhow. So this is called appraisal map. So appraisal map is a map that has a legal description of the property that will be taken from any owner for any widening project or for any something like that. Okay. But if it is a mall, I don't know legally. I don't think that they can go for a mall, because we have to show, because highways and the streets are for the public of California. So they give us the power to obtain it by the law. But for a mall, if somebody has a mall and they would like to expand his mall, and this is Mr. Mansour land, and they told me that I need to purchase this land from you, I can refuse. Say, no, I'm not going to give it to you. And public domain in this case is not applicable, because it's not public, is not something serving the public. Okay, as far as a highway or a street or something like that. Maybe, but probably malls, I don't know if they can go, but that's not the point. The point is the subdivision map. Subdivision map, a map showing the legal boundaries of an area, and an area divided into parcels, lots, streets, and so on. Obviously, subdivision map, I cannot do it. Tentative parcel map, yes, we can do it. Tentative parcel map, preliminary version. And after that, the parcel map, a map showing all the parcels that described, okay, and so on. So this is a chapter that is giving you some kind of, but if you look to the questions, and let me get a clean copy of this book, because this book probably I used it before, or maybe, let's see if I have another book here. The questions are so tricky, by the way, so we need to be careful with the type of the question that you will see on the exam. And after that, I will move to another chapter, have some calculation.
Which book?
The same book.
Oh.
But I need just a clean copy. At least you can. Okay. So if you go to each chapter, by the way, it has some problems at the end. For example, this is chapter 1. Okay, a registered civil engineer obtained his registration after January 1st, 1982. This is on page 49 of the same book, 49. A client asks him to perform the following task: a property survey, topographic survey, design a grading plan, providing no boundary is shown, is taking for grading. Which of the following can he legally be performed? Can legally perform? Okay, remember this is after January 1st, 1982. Can he do property survey? No. So number 1 is out. And I need you to be careful about that. During the exam, you might see a question like this, because this is an easy question without knowing the rest. Number 1 exists in the answer B and C and D. So what is the answer in this case? If number 1, that's it, by the process of elimination, but not all the questions like that. I put the question like that in order to be your attention. But exactly, I need you to be smart. Exactly. If 1, he cannot do 1, but 1 in B and C and D, that means the only answer left is A. And this is the answer. I provide the answers, by the way, at the end of each chapter. You will find there are answers provided on page 52. I provide solutions. Okay. So If you disagree with any of these solutions, please let me know. If you feel there is a typo or a mistake or an error, please let me know, and I'll be glad to look at it and we can correct it together. Don't take me to court. If they find a typo or mistake, don't take me to the court, because court is too much. It's too much. It's very expensive, and I have no time to go to court. We can resolve our differences here. Okay, this I've been saying this for the last 30 years, and I'm glad nobody took me to court yet. Okay, so and so on. Conceptual questions are really tough. For example, number 2, a property owner would like to have a topographic survey performed on his lot. The corners are not set. What option does he have? And he gave you 4 options here. Hire post 1982 civil engineer, hire a post 1987 engineer and a land surveyor. Okay, hire a pre-1987 engineer, hire a land surveyor. So what do you think? Which one is, and look for the best answer. By the way, we are looking what is the best answer, and this is what they are looking for.
Well, by default, hiring a land surveyor, you can do that for sure. So
Yes,
that
that's
would
correct.
be in the answer.
Okay.
So yeah, so you just go straight to B.
Okay, which is okay, but that's correct. This is again the smart way of selecting answers. Okay, for sure, a land survey he can do it. A hire a pre-1982, can he do it? Yeah, yeah, exactly. So I need you to be aware of the type of question. But number 2, hire a post 1982 and a land surveyor. Okay, for sure that he can do that, because we have a land surveyor with him. What is the need to hire 2 people at the same time? But that question, hire a post 1982. Exactly. Okay, so we need to be aware. Okay, topo maps are not okay. The topo map, even he said that he threw something here. The corners are not set. Okay, but as I told you, a corner not been set, I can use a temporary benchmark, and after that, somebody will come to establish the corner for me. And so on. I need you to be aware of this question, and I provide you with answers. For example, if you flip the page, you'll find some answers over there, or some questions. Number 8, for example. Number 8 on page 50. The best method to positively locate horizontally vertical underground high-risk utilities is when you go and do a job or perform, okay, or when we construct a job, it doesn't matter, city, street, highway, freeway, we have utilities underground. We have gas lines, we have water lines, we have cables, we have fiber optics. So there are some utilities they defined as a high risk. High risk, like gas line, like PG&E, because God forbid if you hit a gas line or a contractor's equipment hit a gas line, or it caused a fire, and you remember what happened in San Francisco, okay, or the city explosion, okay. So buttholing, exactly. This is what now in the past we used to have a backhoe, and the backhoe exposed the line. Nowadays they are using more sophisticated equipment, but air jet and water jet. So, but basically you need to identify if I'm planning to have a signal. Okay, we are going to put a new signal warrant. We made the signal warrant, and we are going to put a signal here at this intersection. So they have cabinets here, they have the signal pole here, the signal pole here, and the signal pole here, and the signal pole here. The signal board has a foundation, will go 5 feet down. So we need to know what is really under the ground. Maybe there is a gas line running this way, gas line. Maybe there is a water line running this way. maybe a cable line running this way. So we do this in a process. It's called utility verification maps and conflict maps and so on. I will be glad to explain it. But in order to, if you have a gas line, and the gas line, obviously, how many PSI, pounds per square inch, and the diameter, 6 inches or more, okay? You have to go and expose this line. Because if you contacted BG&E, and with this what we do also, we contact the owner, tell him, what is your line? How deep the line? They tell us, here are the maps, the contractor who prepared for us. But there is no really positive, or there's no assurance from them that this line is at 6 feet or 4 feet or 5 feet. So what we do, we'll go and expose the line. And we put a rod on top of it. And I did this many times. We put the rod on top of it and take the actual measurement. How high or how deep and where it is horizontally. Because the maps that the owner has, like BG&E or any other AT&T or any other company, may be not accurate. And if I provide information and the contractor, God forbid, he hit this line and somebody get injured, or we are responsible, legally responsible. So you have to show him the elevations and tell him, this is the line, here it is, Mr. Contractor, you showed on our plans, and how deep it is. And you need to put the foundations. Don't hit the line. If he hit it, he's responsible. If I didn't tell him how deep is the line, it's a matter of luck, and we are responsible for that. This is why positively, the word positively is very important, by the way. When we are saying that, we are positively underlined, horizontally and vertically, H and V. And right now, they have more sophisticated technique. Like, okay, like the underground radar. Radar right now, they can go and okay.
Vertical borings or horizontal borings?
No, this is no.
Okay.
No, the GPR, the ground radar. I will give you a handout. I discussed this construction. They came up with methods that they can determine the location of the underground utilities without exposing the lines, without hitting, without really buttholing, using some ultrasound and magnetic and radar. And in fact, if you look to the book I was telling you about, which is the blue book. Let's see. Because sometimes they ask these questions, by the way, and the ground radar, and here it is. The radar, here it is, for example, under R, okay, which is radar detection and ranger and so on. So they are using techniques nowadays, okay, using the radars in order to determine the location of the lines under OG. So this, all these things. So please look at it, and if you have any question, I will be glad. As I told you, that calculations are very, very important. And in the surveying exam nowadays, they are really talking a lot about construction. For example, this bucket here, I have a question. This bucket here, the one I gave it to, for those of you here, and anybody who enrolled in the class, we send this, normally we send this bucket. Okay, there is one particular problem. I call it, they are not page numbers, but I have a quiz number 1 and the quiz number 2 and the quiz number 3. I have 3 quizzes, okay? And there is a problem. It says long and good vertical curve problem or statement. Did you see that? Okay. Vertical curve.
Oh, curve. I'm sorry.
Vertical curve. Vertical curve. This is somewhere else. Okay. VC. Vertical curve. Okay. A problem.
So is it referring to this diagram or no?
No, I'm talking about this. Do you see this page in front of you? Do you have it? Okay. That's good. Okay. No, the diagram in the following page. If you flip the page, you will find the 3 diagrams. And this is what nowadays they have. Okay. They have This is the vertical curve. This is a VC, vertical curve, length of the vertical curve. So they have three drawings. They have a plan view, a proposed site for a house or a building, and sidewalk and so on. And they give you another diagram, which is diagram number 2, which is the cross section of the street. And the third diagram is the profile of the center line, which is the center line of the street. Lately, this is what they give on the exam, by the way. Too many drawings, pipes underground, okay, and they give the profile of the pipe, okay, and they tell you what is the elevation of this, what is the elevation of this, what is. So many questions related to this lately, and we need to be ready. And these questions, it takes time. The moment you spend reading this, because to read this, to read the plan view, and I include this problem, by the way, in also in my 497 book. To read this and understand the relationship between the plan view and the cross section and the profile, you have to establish a relationship between them, and they are tied to each other. You should be able to solve these 7 questions. If you go to the previous page, you will find that there are 7 questions related to this. So look to the diagrams 1 and 2 and 3. And you have to do this fast. You have only 2.7 minutes in each question. So in this case, you have to be careful, okay, in all the numbers, and also at the same time you have to be. So I will probably next time I will go over this problem, okay, but I need to make sure that all of you are remembering the vertical curves. And as you know, the vertical curves, yes, the y is equal y VVC plus G1x plus Rx squared. Y at any distance x is equal the y of the BVC plus G1x plus Rx squared divided by 2. Is this the formula you're looking for? Yeah. And as I said, that by practicing you will be able to remember that. But it's not a straightforward calculation.
So what is y at x?
Y at any distance x is equal the y of the BVC plus G1x plus Rx squared divided by 2. Let me translate this into English. Vertical curves, which very important topic. Vertical curves first of all, vertical curves are parabolic curves, not are parabolic, from a parabola, parabolic curve or curves. And there is a reason for that, by the way. Why they are using parabolic instead of circular curves? For 2 reasons, and we're going to talk about them. Vertical curves, they could be either sag vertical curves or a crest vertical curves, crest. Vertical curves, they could be either symmetrical, or unsymmetrical. It doesn't matter if the curve is sag or crest, symmetrical or unsymmetrical, all of them, they use one equation, which is the elevation. We use y for elevation. Y means elevation. The elevation of any point at a distance x is equal the elevation of the beginning of the vertical curve plus G1x, which is entering grade, plus Rx squared divided by 2, the equation I wrote before. So if you look to a sag vertical curve, a sag vertical curve is like this. It has a beginning and it has an end. So if you look to this, you'll find that this is the beginning of the vertical curve, and this is the end of the vertical curve, and this is the two tangents. And the two tangents are intercepting at a point, we call it vertex, VI for circular curve, or we call it VPI, vertical point of intersection. Sometimes they call it vertex, sometimes they call it VPI. They agreed that this is called G1, uppercase or lowercase, G1. And this is G2 or G2. Always like that.
What's that?
D is a grade.
Oh.
Grade, G-R-A-D, grade. This we call it entering grade. For example, AASHTO, they are using uppercase. The textbook, they are using lowercase. This is called entering grade. Entering grade. G2 is called exiting grade, exiting. And this is, if the vertex or the V or the VPI, the curve, by the way, is measured horizontally. Horizontal curves are measured as an arc, but vertical curve measured horizontally. So we take the length of the vertical curve is measured horizontally, not along the curve itself. To the beginning to the end. So L is equal the EVC station minus the BVC station, the beginning of the vertex station.
BVC station?
Yes. End of the vertical curve.
Yeah, we're talking about station.
Minus, yes, station, yes. Station is a distance. A station, as all of you know, it is 100 feet or 100 meters. Metric station or English station. So, if the vertex or the VPI is halfway between the beginning and the end, such that this is L over 2 and this is L over 2, we call it symmetrical vertical curve. So if this is L over 2, we call it symmetric.
Perpendicular to the L, right?
Say it again?
It has to be perpendicular?
No,
L?
not necessarily.
No, you just want to split it.
No, just split it. L over 2 and the L over 2. Okay? So, the equation that you see in front of you here, this is a standard formula in all surveying books, including mine. The Y BVC, this is the elevation of the beginning of the vertical curve. A plus G1X, what is X? X is a distance measured. I need the elevation of this point, point A, for example. I need to know how far point A from the beginning of the vertical. This we call it X. So X is measured horizontally also from the beginning of the vertical curve to the any point along the curve. Any point, yeah, because I need the elevation. Because how they build it in the field, how they build this, we locate these points. We locate these points and they connect them with a nice smooth curve. This is how we build it on the field. Okay, we don't have anything other than just locating points and connect them with a nice, okay, curve, and this will be nice and smooth. So this equation is very important and we need to know how to use it. If you do have a programmable calculator, and many calculators are available in the market, they are programmed. I don't recommend to use, unless you master it, I don't recommend to use programs that already, there are programs available in the market and you can buy them, but I prefer to use the basic equation, this equation here, how to use it. And I have tons of problems in chapter 10. If we are able to use this correctly, we can find what we are looking for. For example, let us solve one problem before we end the session tonight. This one here, probably this picture is a little bit dark, by the way. I don't know the copy machine, but this problem is also available. Let me show it to you in my 497 book. I believe I included also. Let me see, where is my 497? Let me see. In the 497 book, you will find also the same problem. I put it over there because it's very, very important problem. And I need all of you to understand that. Yeah, here it is. Probably the picture is a little bit lighter. Okay, and I can make a copy for you. It's much not as dark as this one here in the handout. But in the 497, if you have the 497 book with you, you will find it is on page 206, problem 123. It's a very good problem, and I always recommend this problem to be solved not once but twice, and because the current exams, they give you a lot. Of these type of problems. Yeah, the 497. A problem 206, page 206, yes, problem 123. I hope that you find it. Here we go. Yeah, it's more readable than the other one. So if you read the question, the ground elevation of the back of the sidewalk at the driveway center line is most nearly. Do you see the problem? Okay, let us read it together. And I apologize for those who do not have it. I will be glad to send it to you guys. I will ask myself to make a copy and send it to you. We need to translate this into English because the difficulty of the exam that they ask something and we need to know exactly which point he's looking for. Okay, where is the sidewalk? This is the sidewalk. Here it is. You see that? From the plan view, this is the sidewalk. And this is the driveway. So he said that the ground elevation of the back of the sidewalk at the center. So this is the center line of the driveway. At the back of the sidewalk, which point he's talking about? This point here. Do you agree or disagree? This point here. I need the elevation of this point.
Yeah, that's the fact the sidewalk is to the south of this photo. So that would be, you're right, that's the fact.
Yeah, because the street is here. How can we do that? The profile, the one he gave you here, the figure 3 or diagram 3, he gave you the center line profile of the street. This is the street, here it is, the main street. And this is the center line, here it is, center line. So the profile along this line is given here. I have a vertical curve of 500 feet, and I have a grade 4.5, and the grade G2 is negative 2.5%. And I know the elevation of the beginning of the vertical curve is elevation 187.71. I know this. Do you remember the station along the center line of the driveway is station 12 plus 25? Here it is. I need to know the elevation of this point, 12 plus 35. I need to get the elevation at this point from this vertical curve. And after that, from here, which is a point K, by the way, from here, I need to go back all the way up to here. So this is the first step I will do. I will say that the elevation Y, and we use always the Y, at station what? Station 12 plus 25 equals to the elevation using this equation. I'm still using this equation here. Okay. So what is the elevation of the beginning of the vertical curve? It is 187.17 is given. Is this correct?
Yes.
A plus. So I finished the first term. which is the Y of the BVC. Sorry, the beginning of the vertical curve. Plus G1X. What is G1 in our case? It is 4.5%. When we are saying that 4.5%, there are two options. You can put the percent and use feet, or you drop the percent and use a station. It is up to you. Most of the books I found that they recommend to drop the percent and use a station. Just much easier to reduce the number of decimal places. So 4.5%, we can drop the 4.5, can drop the percent and leave it as 4.5 times X. What is X in this case? X is the distance from where to where. From the station of the beginning of the vertical curve to the point of my interest. My point of interest is station 12 plus 25. 25 or 35? 25. Minus, what is the station of the beginning of the vertical curve? Station 7 plus 35. So this is the G1X. Any question about that? We need to understand the terms because it's very, very important.
So X is the distance.
From measured from the beginning of the, if you remember from here. So right now I have this station here is 7 plus 35. And the station of point A, this is station 12 plus 25. The point of my interest, which is the center line of the driveway. This is seg vertical curve, but I'm talking about the crest vertical curve.
So the station is X?
I beg your pardon?
The station is
X
X.
is a distance.
Right.
Distance, which is the distance between the 2 points. That's correct. And I drop the percent, and here it is.
Yes.
This is X. And this is a G1. A plus. The third term, which is Rx squared divided by 2. What is R? Do you remember the sample problem? R is equal G2 minus G1 divided by L. So I will put R as G2 minus G1 divided by L. G2 in my case is negative 2.5. Minus G1 is 4.5. And L is going to be 5. I drop the percent, I use stations, 5 stations. This is R. X, we just found it here, which is the difference between station 12 plus 25 minus 7 plus 35, this quantity square, and I divide by 2. Do you see that? This is Rx squared divided by 2. Here it is, because part of the equation. Rx squared divided by 2. This is part of the equation. This is 2, yeah, I'm sorry. Okay. No problem. So if we do this math, I don't know what number you got. If you can do this for me, and you have to do this fast, you have only 2.67 minutes. So by practicing, yes. I'm sorry that my handwriting probably is not the best handwriting, but forgive me for that. Because you have the solution already typed for you. But I need you to practice using your calculator. And how to add and subtract stations, you should master that. Any luck? You get a number for me?
I'm using my calculator. Yeah. So,
So you got it? Just to save time, so we can
go ahead.
do it. This 192.41 feet. If you do this math, assuming my numbers are correct, I believe 192. Okay, so right now this elevation here, the 192.41, where is that? This is the elevation at this point here. I called it K. This is the elevation at along the center line at this station. Okay, I need to move from here to here. So based on the cross section right now, here it is. What is 2.5% negative? No, 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 no.
Oh,
This from the section AA. If you look to the, this is a vertical curve. We are done with that. So right now the elevation here along the profile grid BG, PG stands for profile grid. This is the elevation I just found. Here it is. How much is this elevation? Is 192.41. 192.41. So I am here along the center line. No, no, but you can do it differently. I beg your pardon? No. No, 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 no. Just give me a chance, and you will may disagree with me or agree. So I am here right now. I need to go up 0.12. This will put me here. And this is a level line. That means the elevation here is the same as this elevation here. Because this is from the cross section. Because as I told you, I am here. I need to go all the way up to here. So in this case, so 192.41, I will add 0.12 to get me here to the curve, okay? To the top of the curve. Right now, we have a sidewalk of 10 feet. But be careful. The sidewalk is sloped a 1/4 inch per foot. So every 1 foot, I have a 1/4 inch. So for 10 feet, how much I have? I have 2.5 inches. This is what he said here. Yeah, 2.5, which is 10 divided by 4. So if I take 192.41, if I add the 0.12 that they give it me in the problem statement here, 0.12, and I will add another 2.5 inches. If you add all this, can you add this, please? But remember, this is feet and this is feet. The 2.5 inches, you have to divide it by 12. Don't forget that. Units are very important. Yeah, because this 2.5 inches, this is feet. Because this, okay, so if you add 192.41 plus 0.12 and convert 2.5 inches to feet, add them up, hopefully you can find an answer to match any of these answers. What did you get? C, 192.74, and this is the correct answer. Yes, but don't forget to convert the 2.5 inches. This is a kind of problem that you might see on the exam. They are not straightforward. They are not just telling you, do this and do this and do this and that's it. Yes. Say it again. A property line. Yeah. He's talking about this. PL. Abbreviation here, property line. So I need you to be aware of that. And for those who are not having the book or they are not here with me tonight, but can you do this in 2.7 minutes?
With practice, yes.
Yeah, with the exact, I like this answer. Yeah, with the practice, yes. You put conditional statement at the beginning. With the you can do it. Yes, we can. Do you remember our President Obama? Can we win? Yes, we can. Okay. Okay, that's good. Okay, so the answer is C. Yes, I thank you very much. Okay, my friend, the one online also got this. So I need you to do your best, and I will do my best. So we'll stop here. For those who enrolled in my class, you have access to the on-demand 24/7. If you have any problem with the on-demand, please let me know. I can help you, but you need to watch. You'll find 42.5 hours lecturing. You need to get into on-demand and listen to the lecture, and based on my current book, and come here, we can discuss issues, we can discuss topics, we can solve problems together. But the concept, I need you to pay attention to the textbook. The textbook already, as I told you, it's available for you as an on-demand. On-demand means that the whole course is for you 24/7. You can access anytime. And we give you the password and the ID. If you have any problem, let me know and I will ask my staff to help you. I need.
What homework are you giving us? Or which ones should we be doing?
Okay. Okay. Next couple weeks. What if I were you? I will do the following. I will cover from chapter 1 to chapter 5 from the textbook. Okay. Yeah. From the textbook. Yeah, this one here. You're supposed to, okay, and solve all the problems. Is the textbook. Book number 1. You can number them. Number 1, number 2. This is the one. The one has tabs. There is only one book has tabs. Is the textbook. This is a okay. 1 to 5. You're supposed to watch the on demand because you have access to it, and you're supposed to solve all the problems. And when we meet next time, I will go over any problem that you have difficulty with, any problem that you have access a problem with it. Yes, they are complete. Okay. So there are some problems, but don't worry about the handout. I will focus on the book right now. Let's finish the book. Let's finish the 15 chapters. And after that, we'll jump on the 497. Okay. But because the problems on at the end of each chapter, they are very, very good. So from chapter 1 to chapter 5, including chapter 5, okay, to the end of chapter 5, which is leveling. It's a very important chapter. And I heard they have a lot of questions about leveling lately. Okay. So the date is correct. That's correct. Yeah. Again, yes. Okay. Yes. So I hope that all of you will be ready by that time, and I will be glad to provide you with any information that. So do your best, and I will do my best, but it needs an effort from your side, and I will be glad to help you guys as much as I can. Okay. Okay, good night, everybody, and do your best, and I will do my best. You are very welcome. You are very welcome. Yeah, if you email me, I will be glad to send you the handout. No problem. If you don't have the handout, I'll be glad to send it to you. Okay. Good night, everybody. Bye bye. Okay.
I do need to go to the bathroom real quick before I do.
Oh, you are very welcome. Yeah. Yes.
Do you have any questions for
No, she's. Okay.
What's
So
that?
what question do you have for me? Yeah, sure, take your time.
Yeah, I have a couple of questions. First one is I want to ask you some advice. I submitted my application to the board in last November.
Okay.
Okay, I haven't received the approval yet. But most likely I'm going to take the exam in next quarter,
Okay, the second quarter.
the second
okay.
quarter,
Yes.
because they need a quarter time to schedule the exams, right?
Mhm.
And but I will start review.
That's fine.
Okay, and the first question is what's different between the first quarter and the second quarter about your materials? Because I felt
The second quarter. you
yeah, you change some textbooks, right?
And I'm going to start the second edition in April. Yes.
Yes.
The difference is minimum.
The minimum, right?
Minimum. I just rearranging some topics, some improvement, but the current set of books have been used for the last very long time, and everybody is having a lot of passing. You search it on the internet, search it on Google, you'll find the book is really highly rated by the engineers who use it. But I need to improve my books. Always there is improvement. So I am improving my books. So the second edition will be released in April.
For the
start
survey,
the
right?
class again. Survey, that's correct. That's
Okay.
correct.
And for the seismic, you already changed it to the
That's
new,
correct. I'm going to start teaching tomorrow.
Is that a new
New code.
new
Yes.
code and a new
Yeah.
code with coordinate with the board, right?
Yes.
And for which means for the seismic, there's no problem, right? For the survey, they only have a minimum change, right?
Say it again.
For the survey, you only have a minimum change.
Yes. If you attend now this semester, and because you will be entitled to take the course again with me
Okay.
next semester, and I will give you another set of books of the second edition. You will find the difference is minimum.
Okay. So which means if I attend now, the second quarter I still can attend your class.
Because we give 150 days.
150 days. Yeah.
Yes, 50 days will cover the first quarter and portion of the second quarter. So normally we give the entire quarter for you guys.
Okay. And
The seismic, there is a changes because they're using a new code.
new code.
The ASC 7, 16, and they're using the IBC 2018. The changes are not drastic. The
Yeah,
changes are minimal.
I called your assistant
Yeah.
last October.
Yes.
That's why she said, okay, if I'm taking in this year, I better take the course in this year because something is changing.
That's correct. That's
So
correct.
yeah, that's why.
When you are going to take the size, when you are going to take the size,
For the course or for the exam?
not the exam.
I think I want to take the same time for both.
Oh my God, it will be. It's a good decision. No, most likely the gate is locked. When you go down the gate, let's go together so we can
Okay,
talk.
yeah.
Because the secure, maybe.
Go down together, okay.
Maybe, okay. Let's,
I'm sorry, what is your name?
Oh, my name is Chumo.
Jumo?
Yeah.
Nice to meet you. I'm Jennifer.
Yeah, nice to meet you
So
too.
how do you spell your name?
My name is start at Q
Uh-huh.
ING MENG.
Jumo.
Yeah.
That's a tough one.
Like the review course, right? We need a little bit
Like which one?
like the review course, exam, right?
Oh, right,
We
right.
need a little practice.
Right, yeah, exactly. You practice.
Yeah.
Yeah.
oh, I'm sorry. I did not end the session for some reason in the webinar this way.